All right. Good morning, everyone. It's a pleasure to have the chance to share some thoughts. This is an overarching theme of the work we do at the Network Systems Security Group at KTH. It has started quite some time ago, and the development of the Internet of Things, of course, even earlier than that. So if we turn the clock back, I was still fresh after my PhD then. This non-technical journal says that, well, everything connects and it's very important for all facets of life. But then a decade later, they're so unhappy about what is happening in terms of security. Everything is broken, they declare. You might not subscribe to this fatalistic, let's say, view, but as we just heard in the introduction, I would posit that well, smart environments could become horror environments unless we design security and privacy correctly. So to that end, I will highlight 3 challenges and then juxtapose them with 3 ensembles of work that answer those and offer solutions. So first challenge, well, it comes from the front page of the journal I showed you, when everything connects. Well, scale. So you see here the sheer scale or the impression of these pictures, these illustrations of different forms of IoT I show. And the challenge is that we need to build security and privacy, I'm choosing the words here, that are tailored to the new dimensions. On the one hand, the number of devices, users, service providers involved. On the other hand, the fact that we cannot leave any part of this huge system of systems unfortified. And this new landscape comes along with new requirements, which in terms of scalability magnify the challenge. And this will become clear in the next slide. The second challenge is trust management, and connected a little bit to some earlier talks. We want to provide both security and privacy. That's an underlying challenge. And we need to be clear on what are the identities of the entities involved and what are their credentials, what are they allowed to do and not allowed to do in the system. And we need to keep track, and that was an interesting slip of the tongue, of the fact that any interaction of these devices, users, with other users, other devices and service providers leaves a rich trace behind. So this is an alarm in terms of privacy and sensitive information that is left behind, especially if this is verifiable, because we have the security aspect in hand. The third challenge has to do with verifying physical world properties. In particular, here raise location. You see the satellites, which provide a ubiquitous solution for positioning and time. And then you see the little devil at the left corner, injecting its own signals that basically, and these correspond to real attacks, very real, very impactful, that basically control the location and the time on the victim, meaning the platform being a boat, a car, or a container that has a GNSS global navigation satellite receiver. So how can we rely on all these systems, which are great for the efficiency of our business and everyday life, if someone can basically tell us where to go, and we are not there in reality? So let me shift gears and talk about the matching solutions to these challenges I raised. Well, relating to scalability, but also to trust management, so I blend these two together, we need to build systems that essentially perform a balancing act between security, or among security, privacy, and efficiency. And here I show an example of a system that evolved over the years, inspired or built for connected vehicles or vehicular communication systems, essentially the technology that will lead us to autonomous vehicles a few years down the road. So there we have security, and at the same time we have a requirement for privacy. And what we realize is that the order of magnitude of credentials that we have to deal with is 5 orders of magnitude above what traditional certification authorities handle nowadays. At the same time, you have real-time constraints that come from, you can imagine the scenario, two vehicles that need to communicate before one performs an emergency braking or notifies its driver. And we do have, if I want to jump ahead, a system that with modest computing resources, Traffic Verket, if it wishes, in a very short, could adopt and deploy what you call intelligent transportation systems throughout Sweden. Now, the challenge of privacy, the reduction of user exposure, is not automatically solved by having the appropriate anonymized credentials that the previous system provides. In fact, if someone is very careful and observes, it could put the dots together. So we need to have additional measures that essentially hide those that don't want to be shown. And then at the bottom right, you see a system that utilizes some roadside infrastructure to do so. What is more interesting, perhaps, because we are facing it every day, is the interaction with service providers, location-based services, and that relates to the area of work that Cihan talked in the video before. Every time you interact and you ask a question about where are the closest restaurants and so on and so forth, you reveal information about who you are, where you want to be, and what you like eventually. It depends on these questions. So we proposed architectures which leverage the system I showed you before, but also reduce the exposure of the user from or to a otherwise correct and honest but curious service provider that wants to basically, as a glutton for private information. And we have a security and privacy architecture that solves the problem that eventually we showed, and you can see at the poster Cihan presents, that participatory sensing actually opens a fundamental vulnerability there. Now, to conclude, the third challenge, the secure location, well, let's focus only on global navigation satellite systems. Well, you have an attack, and at least you need to know that you are under attack. And even better, you want to know what is the best or most accurate location that you can count on. Why? Because if anyways your signals are overwritten by the attacker, you have no access to the satellite signal. So can you do something towards those two ends? And here I'm showing you what I think is a realistic solution that could be applicable and deployable tomorrow, that augments existing receivers with onboard processing capabilities, access to alternative sources of information, to basically give you exactly this, what you see, the globe with somewhat not so accurate location and time, but let's not expand on this. Why? Because you are under attack, and still this is great, and clearly a trustworthy notification. So now, how could one do such a thing? Well, here you see some examples of attacks and some attacking gear, but you can hear more about this when you see Marco's poster and more modern attacking apparatus. So how do you do this? We can be agnostic to the attacks. We can say, hey, okay, is the attack changing the location and the time of the victim receiver? Well, then let's juxtapose this to alternative sources of time, whether it is our onboard clock that is ticking at a good quality, at a good pace, or if it is information we can get over the internet, or whether it is location we can compute with the help of other infrastructure. How on earth could we do this? Well, it so happens that no GNSS receiver, in most cases, is a standalone device. It is usually integrated in a platform that has connectivity and sensing capability. So why don't we leverage this, even though it doesn't give let's say, the neatness of the localization that GNSS provides. And in fact, we found that this gives a great deal of very accurate detection and then provides a substrate for early detection and, based on the prior knowledge, a good estimation of the current location, even though the GNSS is under attack. And we're expanding this into settings where not even this side infrastructure is fully trustworthy, because that's the world we live. You cannot trust anything a priori. So this is essentially the, this is the set of challenges and solutions that I would wanted to share with you. And I do believe that if we focus on securing or rendering trustworthy key enabling technologies, even in this very complex, perhaps chaotic landscape, we will manage to really make strides towards trustworthy Internet of Things, towards trustworthy smart environments. Thanks very much.
Thank you. Yeah, you say yourself a chaotic landscape. So there are millions of types of Internet of Things, everything from toys to heart monitors to industrial applications. How do you actually develop security solutions, or how can you keep up with all of these applications? And because you need to develop so many different types of technologies.
Well, this is something that we have done anyways for what you would call the classic Internet. Let's say if you think the beginnings, and then how many applications sprung up. I mean, we are learning as things emerge, and it's always an arms race, meaning typically the market deploys, provides products, and then everyone realizes there are weaknesses, and then you have to go and patch up. And then you have to decide how much you want to eventually invest ahead of time so that you don't always run after the developments and then pay the price. I mean, because there is a real cost eventually if your product loses face and people simply return the gadget or no longer subscribe to your service because it's either vulnerable, unsafe, or eventually violates your privacy without your consent.
Thank you, Panos. And yours already advertised that part of your research group is at the poster exhibition,
yes,
where you also be, if any of you would like to talk more. Thank you so much for joining us today and shedding light on this area.
Thank you very much. I would be delighted. Thanks.